Now this question number 9 is a slightly difficult question among all the questions in this test paper. So we have to find out the integral pairs for x and m such that it will satisfy the given inequality, given equality that has some modulus signs. Okay. Now for this, we'll be dividing this entire solution in different cases. Now, first of all, we'll make cases based on the values of x. So the value of x can be equal to 0, it can be greater than 0, or it can be less than 0. Similarly, for the second modulus m minus 1, we can take m minus 1 to be greater than equal to 0 or less than 0, right? So there will be, I think, a total of 5 or 6 cases. We'll exploit one by one. So the first case will be when x is equal to 0. So I'll separate this case out. So when x is equal to 0, the entire equation will be modulus of m minus 1 equal to 0. Okay, so modulus of m minus 1 will be equal to 0 when m is equal to 1. So the first set of value for x comma m will be 0 comma 1. All right, so this is the value that I have got from the first case, which is 0 comma 1, right? Now the next case, when x is greater than 0 and I can say m minus 1 is greater than equal to 0. So you must have noticed that I have separated x equal to 0 and I'll be considering x greater than 0 and x less than 0, right? So x greater than 0, the second case, and m minus 1 greater than equal to 0. That means m will be greater than equal to 1. So our equation will be x square minus 2x. Now since m minus 1 is greater than 0, so the second modulus will be positive. So it will be plus m minus 1. All right. Okay. So it will be equal to 0. So x square minus 2x plus m minus 1 equal to 0. I'll try to convert the expression of x in perfect square. So x square minus 2x plus 1 plus m minus 1 minus 1. So plus 1 and minus 1 मैंने कर दिया है to balance it out. So it will be x minus 1 whole square is equal to 2 minus m. Okay. Now m is greater than equal to 0. Sorry, greater than equal to 1. So the values of m will be 1, 2, 3, 4 and so on. But the left hand side of this equation, x minus 1 whole square, will always be greater than or equal to 0. It has to be positive always, right? So the values of m for which this will be positive will be m equal to 1, or it can be 0 as well. So m can be equal to 2. So the values that m can take will be either 1 or 2. Now if m is equal to 1, the right hand side will be equal to 1, 2 minus 1, and the left hand side here, x can be equal to 2. Okay, so x equal to 2 and m equal to 1 will be one of the solutions. Similarly, if right hand side m is equal to 2, so right hand side will be equal to 0. Now left hand side will be equal to 0 when x is equal to 1. So other two solutions here will be 2 comma 1 and 1 comma 2. So we already had one solution from case number 1 and two solutions from case number 2. Now let's look at the third case. Now case number 3 will be when x is greater than 0 and m minus 1 will be less than 0. That means m will be less than 1. All right. So the equation will be x square minus 2x minus m plus 1 is equal to 0. So I can write it as x minus 1 whole square is equal to m. Okay. Now m will be less than 1, and this right hand side, sorry, left hand side x minus 1 cannot be negative. So m can only be equal to 0. So if m is equal to 0, the value of x will be equal to 1. So 1 comma 0 will be the fourth solution of this equation from case number 3. Now looking at case number 4. Now this case will be when x is less than 0. So for x less than 0, again two cases will be made. So the first case will be m minus 1 greater than equal to 0. That means m will be greater than equal to 1. So x less than 0. So x square will remain x square minus 2 modulus x. So it will become plus 2x plus m minus 1. All right, is equal to 0. Then again trying to make it a perfect square. So x plus 1 whole square. So it will be equal to 2 minus m. Okay. Now x is less than 0, x will be negative, and m will be greater than equal to 1. Now x plus 1 whole square will always be positive, so we will have to keep right hand side positive once again. Okay, so m can be 1 or it can be 2. Correspondingly, the values of x. So if m is equal to 1, the right hand side will be equal to 2 minus 1, that is 1. So I can put x as minus 2. So minus 2 plus 1 will be minus 1. Minus 1 whole square will be 1. Okay, so x equal to minus 2 will satisfy. And x equal to minus 1 will be when m is equal to 2. So these are another two solutions. Okay, this one and this one. So up till now we have a total of 6 solutions. Now the last case, when x is less than 0 and m minus 1 is also less than 0. So equation will be x square plus 2x minus m plus 1. So x plus 1 whole square is equal to m. Okay. Now m minus 1 is less than 0. That means m is less than 1. So m less than 1. But left hand side is always positive. So m can only be 0. So left hand side cannot be negative. So m equal to 0 and x will be equal to minus 1. So that's it. These are the 5 cases. From these 5 cases, let's count how many values or how many pairs for x comma m do we have. So this is one pair, second, third, then fourth pair, fifth pair, sixth pair, and the seventh pair. Okay, so in total we have 7 integral pairs for x comma m. So the answer for this question will be 7.